Welcome all of you to another video of Maths Made Easy Academy. Now here in this video we are going to take up electricity numericals. Now I am going to take up electricity numericals for quite some videos now. So at a stretch there will be all types of electricity numericals, like I will be taking up power type questions, I will be taking up internal resistance type questions, I shall be taking up sums based on V is equal to IR, also if specific resistance questions. So each type of questions I shall be taking up one after the other. So here in this video I am taking up finding equivalent resistance. How do we find equivalent resistance in a circuit? Okay, so let's start first, because in this what is a parallel connection and what is a series connection? Let us know that first. A parallel connection is if there are many resistors, there can be any number of resistors, okay, they are all connected like this. That means there is only two common junction points. Current goes here and then splits into three parts according to the resistances. This is parallel connection, okay. This type of connection is parallel, whereas a series connection is this, where they connect the resistances one after the other. So here is one junction point and here is one. So here we find the equivalent resistance between these two junction points, that is in parallel, okay, and equivalent resistances between A and B, okay. From here till here we find the equivalent resistance in case of series connection. So this is a series connection. Now what is equivalent resistance? Equivalent resistance is that resistance which equivalent resistance is that resistance which represents the only one resistance of the full circuit, okay. It is the total resistance of the circuit, okay, the resistance that is working on that, the only value of resistance which works in the circuit, okay, the only one value of resistance, that you can say, in other words, the total resistance in the circuit, that is called equivalent resistance. So let us do few sums so you will know. Here the sum says two resistors 8 and 12 ohms are connected in parallel, okay, 8 and 12 are connected. Now drawing the diagram is absolutely essential, it will reduce your mistakes. Now these two are connected in parallel, this is junction A and this is junction B, okay, these are connected in parallel, find the equivalent resistance. Now the formula for parallel equivalent resistance when the circuit is in parallel is 1 by R, which is 1 by, you can say, R1 plus 1 by R2. This is 8 ohms and this one is a 12 ohms. So here R1 is 8 and R2 is 12. So this is 8 and here is 12. This is how much? This is 8 and 12. This is the LCM of this will be a 24, okay, LCM is a 24, this is 3 plus 2, 5 by 24. Now many people do the mistake, as you know, they say R is 5 by 24, R is not 5 by 24, 1 by R is 5 by 24, so R is 24 by 5 ohms, which is 4.8, okay, which is 4.8 ohms. So that is the equivalent resistance when they are in parallel. We use this formula, so you have to remember this formula, okay, and always remember to write the reciprocal of the value that you find, because 1 by R is equal to 5 by 24, so R is equal to 24 by 5. Now let us take up another question. Now the diagram for this is somewhat like this: 4 resistors and each one is having a 5 ohms. So here is the diagram, see, okay, and so 4 resistors each having resistance 5 ohms. So 5 ohms, 5 ohms, 5 ohms and 5 ohms, each one is having resistance 5 ohms between these two. So this is a kind of parallel connection that they are talking about. So in this case, how can we do a shortcut? Actually it is 1 by R, which is 1 by 5 plus 1 by 5 plus 1 by 5 and 1 by 5. So why don't we do this 4 by 5? Okay, just a little shortcut. So 5 is 5 by 4, which is 1.25 ohms. So the equivalent resistance in this case is a 1.25 ohms. Okay. You have three resistors of value 2 ohms, 3 ohms and 5 ohms. How will you join them so that the total resistance is less than 1 ohm? So they have told three resistors, the resistances are given and you have to join them. Now they didn't tell you whether it is going to be parallel or it is going to be series. Okay, so how will you join them so that the total resistance comes to less than 1 ohm? Now very clearly one thing is there, that if we have them in series, okay, if we have them in series, the formula for series is R1 plus R2 plus R3. That is going to be 2 plus 3 plus 5, which makes 10 ohms. But definitely 10 ohms is more than 1. So we will try parallel now. We will try parallel connection with these. So what we will do is draw a parallel circuit and let's see. So this is 2 ohms, 3 ohms and 5 ohms. And here is A and B, the two junction points, and this is my parallel circuit. Let me see what is the equivalent resistance. 1 by 2 plus 1 by 3 plus 1 by 5. Okay. Now remember one thing, whenever we do parallel connection, the resistance of the circuit actually reduces. Whenever we do series connection, the resistance increases. Okay. So here we'll see the LCM is 30, 15 plus 10 plus 6, which is, okay, so R is how much? R is 30 by 31, which is a proper fraction, which is clearly a less than 1 value. Okay, how much is it? 30 by 31 will come to something around 0.96 ohms. Okay, so we should arrange them in parallel and not in series. Okay, and here also you see again that when we connected them in parallel, the resistance has become smaller. Okay. Now note one thing, I am doing these sums from the latest edition of Concise Physics. Okay, so this is latest edition of Concise Physics. I have started taking from question number 6. Okay, so I am doing one after the other the sums that are about this equivalent resistance only. So you can now 3 resistors each of 2 ohms are connected together so that their total resistance is 3 ohms. Okay, now they are not telling us what is the, what kind of connection they have made. Is it a parallel or is it a series? We only have to find. Now if they are in series, then if they are connected in series, then it becomes 2 plus 2 plus 2. Okay, 2 plus 2 plus 2, which makes us 6 ohms, but we want a 3 ohms as equivalent. So what to do now? Now if we connect them in parallel, all 3 in parallel, okay, then we'll have 1 by R is 1 by 2 plus 1 by 2 plus 1 by 2, which is 3 by 2. Okay, then R is 2 by 3, which is 0.6 and not 3. Okay, so that also does not work. Now let me see what else we can do. So we can maybe keep 1 as in series and then 2 in parallel. Okay, let's see this, what happens. Okay, so this is something you have to try out little bit. So here this is 2 ohms, 2 ohms and 2 ohms. Okay, now how much is that? Let me find for this first. 1 by R is 1 by 2 plus 1 by 2, which is 1. R is equal to 1 only for this portion, only for the parallel portion. So the circuit now changes to 2 and then this is a 1. Okay, so 2 plus 1, the equivalent resistance of this part is a 3 ohms. Okay, so I can take this as R. If you take this as R, let me take this as R dash, that is 3 ohms. So this is the correct arrangement of the circuit so that I can get a 3 ohms total resistance, and that diagram is a must. So here is the point A and that is the point B, and in this sum, the 10th question, they have given all of these as 2 ohms, 2 ohms, everywhere it is 2 ohms only. Okay, so all these are 2 ohms. Now they want us to find the equivalent resistance between the point AB. Now remember one thing, it is very important to take note of the two junction points in these resistance questions. So here I can see series, but then here it is parallel. So let me first get the parallel resistance, which is half plus half, which is 1. So R dash is equal to 1 ohm. Yes, R dash is equal to 1 ohm. If R dash is equal to 1 ohm, then I will now get my entire circuit now becomes like this. Okay, this is B, this is A, this is 2, 2 and 1 now. Because this part now is considered in series along with these two. So my resistance now, the final equivalent resistance or the total resistance is a 5 ohms. Okay. Now this is one question where three resistors are in series, four similar sets are connected in parallel. If the resistance of each, now there is a slight difficulty in understanding this question. A combination of three resistances are in series, three resistors. Okay, four similar sets are connected in parallel. Resistance of each resistor is a 2 ohms. Let me first draw three in series. Okay, this makes one set, okay, and four similar sets. So I will now have to make four similar sets. Okay, so these are the four similar sets of three each, of three resistors each. This is what the sum wants to say. So here I will connect them to one common junction point. This is the sum. Okay, so this is A, this is B, and here it is. Okay, then this is, each one is a 2 ohms. Okay, each one is a 2 ohms. Each one. This is the complete picture. Okay, so each one is, so here four of them are there, and each these lines, each one they are calling one set of three resistors. Now find the resistance of the combination. So first thing is, this full diagram changes to what? It changes to something like this. See, it, if you can imagine it like this and like this. Now what? Each one is a 6, 6, 6 and 6. This is what it is actually. Okay, because these are in series. So here I will apply the series formula, 2 plus 2 plus 2, 6. So 6 I have in 4 sixes I have in parallel. So my final formula is equivalent resistance is 4 into 1 by 6. 4 by 6, that is 2 by 3, that is R is equal to 1.5 ohms. Okay, R is equal to 1.5 ohms. So this is the final equivalent resistance is 1.5 ohms. Okay. This is the new question. This is the 12th question. They have given us a diagram like this. 8 ohms, 4 ohms, 5 ohms and x ohms. One of them is not given. Okay, so 8, 4, 5 and x ohms, and they have given the equivalent resistance of the full circuit as a 4. Now we will have to find the value of x, this resistance. Okay, so let me first take, this is actually 12, right? 8 plus 4, 12, and this is 5 plus x, right? So I will redraw this diagram and see. This is what, this makes it very difficult, very easy to understand. A, B, this is 8 plus 4 and this is 5 plus x. Okay, so now I will be finding the equivalent resistance. So equivalent resistance 1 by R is equal to, now since this is a parallel connection, I am using the parallel formula. First I have used the series, 1 by 12 plus 1 by 5 plus x. Okay, this is 1 by 4 is equal to 1 by 12 plus 1 by 5 plus x. Now 1 by 5 plus x, 1 by 5 plus x is equal to 1 by 4 minus 1 by 12, which is 12 here and then 2 here, which is 1 by 6. So 5 plus x is a 6. Okay, so 5 plus x is a 6. In that case, x is a 1 ohm. So x becomes a 1 ohm. Now they want the effective resistance of this circuit in question number 13. Okay. Now the first thing is, I have to observe this question. This is 1 ohm. Okay. 1 ohm, 1 ohm, 1 ohm. 2 ohms, 2 ohms, 2 ohms. And this is 2. So first I will not think about these 2 points. First I will think about this and this. Now note, I can make this like this, something of this kind. I can make it like this, and then from here I can write 1 plus 1 plus 1 because this is a series. Okay, here the current is not getting bifurcated into any other line. It is whatever current. How do I understand if it is in series? If it is current is going through this, it has to pass through this and has to come down through this. Okay, here also current going through this will pass through this and will go through this. So here this is, now I can take it something of this kind. Okay, and here this is again, you see, one more parallel connection. So this I can write as a 3, this is already a 2, and this is a again 6 because of this series connection. Okay, this also is actually a series. Okay, here is 1 and here is 1. So now I'll first find the R dash, 1 by R dash, that is for this parallel connection, let's say between P and Q. Okay, so resistance between P and Q I will find first. This is R dash, is the one between P and Q, which is 1 by 3 plus 1 by 2 plus 1 by 6, which is equal to 6 LCM 2 plus 3 plus 1, that is 6 by 6, which is 1. So the resistance of this portion R dash becomes a 1 ohm. Now the figure changes to what? The figure changes to this 1 and then 1 and then 1. 1 ohm, 1 ohm, 1 ohm. So the equivalent resistance of this circuit becomes a 3 ohm, because here after that we can consider it as a series connection. So it becomes a 3 ohms. Now here is a question. There is a wire which is 27 ohms resistance wire and it is divided into 3 equal parts. Okay, so if you are dividing a wire into 3 equal parts, then you see, let me actually tell you what happens. R is equal to rho L by A. Okay, now the length of the wire which has been divided into 3 parts. So the new R dash becomes rho because it is the same wire, A because the area of cross section does not change, and L now becomes L by 3 because it has been divided into 3 equal parts. Here the R value was a how much? It was a 27. Okay, now here how much has it become? So can I do this? RLA into 1 by 3, right? I have just moved the 1 by 3 out. Rho LA is a 27, by 3 it becomes 9. So the equivalent resistance of the new one is a 9 ohm. That is the new small piece. Okay, resistance of the small piece, the 3 pieces are 9 and 9 ohms. So they are joined in parallel. So let me draw the diagram. Just in case you have not understood, you will understand this now for sure. So this is 9 ohms, 9 ohms and 9 ohms. This is what it becomes with the 3 parts. So 27 length, 27 ohm wire, when you split it into 3 equal parts, it becomes 9, 9 and 9 for this reason that I showed you here. So 1 by R, that is the final resistance, is equivalent resistance. Okay. Let me take it as R double dash. First it was R, okay, then it was R dash for the small pieces, and now it is R double dash, which is the equivalent resistance, which is 3 into 1 by 9, which is 1 by 3. R double dash is 3 ohms. Therefore, R double dash is a equivalent resistance of the circuit is 3 ohms now. Okay. So keep noting, I have told you one thing, that when it becomes parallel, the final equivalent resistance reduces. So that was 27, okay, and even after splitting it was 9, finally you put it in parallel and it becomes 3, okay. Now the question says, the question is like this: find the equivalent resistance between the points A and B and A and C. Okay, find R between A and B and A and C. This is the question, and this is the reason why I picked up this question. Okay, between A and B, if they say that, that means you have to understand that the rest part of the circuit is like this. It is here. Whatever other things are over here. So these become the 2 junction points. In that case, the circuit can be seen like this. Okay, it is somewhat like this: A, B. These two are in parallel. These two are in parallel. So this is 2 and this is a 6 because 2 plus 2 plus 2 that becomes in series. Okay. So and if we say between A and C, that means the circuit is from here and from here. That is, the circuit becomes somewhat like this. See. And see, this is A, this is C, and then here these two become series. So it is a 4 ohms, okay, and here again another 4 ohms, okay, this is a 4 ohms. So this is the basic difference between, that is why I am saying always keep looking for junction points. Which is the junction point? You just can't see it and start doing it. You have to see which are the two junction points. So between A and B, you see answer will be different. Between A and B, let's find R, which is equal to, this is a parallel, 1 by 2 plus 1 by 6, which is a 6, 3 plus 1, which is 4 by 6. R is equal to 6 by 4, which is 3 by 2, which is 1.5. Okay. So this is 1.5. Okay, this is 1.5 for this kind of a between A and B. Now if you take this, it is here, let's take 1 by R dash, and that is 2 into 1 by 4, that is a half. So R dash is equal to 2 ohms. Okay, so complete different answer in both the cases. That is a 2 ohms and this is a 1.5. So this is one of the very important questions. Okay, I consider this as the most important question in the full chapter. Okay, another important question, if you say, is the question where we had 4 similar sets. That I consider a very important question. Okay, so that is it in this video. So we have taken up only resistance, finding equivalent resistance, different circuit diagrams in this. In the next video, we shall be taking up more questions on electricity. So please keep watching, and if you haven't subscribed the channel by now, please subscribe it, because I shall be uploading many more videos as the exam approaches. Bye then, thanks for watching.